5 in the morning at Bingham Canyon. The first shift hasn't finished loading the trucks from the night blast yet. The pit is 800 feet deep by this point, and the benches are cut into red-brown rock that hasn't seen daylight in 100 million years. A truck backs under the shovel with its bed raised slightly. The operator knows the angle. The bucket swings across the morning air, dark against the Utah sky, and dumps 40 tons of copper ore into the truck bed. The truck is a Caterpillar 769, yellow paint over steel. Not the biggest machine in the pit, not the loudest, but when it starts rolling, when it loads those first 35 tons and points up the haul road toward the mill, it does something that no truck of this size has done before. It moves. This is a machine that shouldn't exist yet. In 1963, off-highway trucks were supposed to be slow, fragile things. They were supposed to break down. They were supposed to cost you money. This truck does none of those things. It's the first truck Caterpillar ever built for mining, and it's about to change everything. Before we go further, if this kind of history matters to you, consider subscribing to the channel. Every video here is built around the machines and the men who ran them, the haul trucks, the shovels, the open pit operations that fed American industry for decades. If that's worth documenting to you, the subscribe button is how you tell us. And we want to hear from you. Did you work in a mine, open pit, underground, processing plant, maintenance shop? Did a father or grandfather run haul trucks, operate a shovel, work the blast crew? Did you grow up in a mining town in Arizona, Nevada, Montana, Wyoming, West Virginia, or Minnesota? Leave it in the comments. The people who actually worked these operations know things that don't appear in any company report. We want to hear from them. Now, back to the operation. The 769 didn't appear overnight. Caterpillar had been watching the earth-moving equipment market since the 1950s. They knew that off-highway haul trucks were coming. They just weren't moving fast enough to meet demand. So in the late 1950s, they started building 4 pilot designs, 4 test phases, every failure teaching them something the truck needed to be. The man driving much of this development was an engineer named Ralph Kress. Kress had worked on something remarkable a few years before, a truck built by Latourneau Westinghouse called the Haulpak. The Haulpak, introduced in 1958, changed everything about how off-highway trucks were designed. Revolutionary suspension using hydro-pneumatic struts, a fabricated mainframe instead of the old heavy rolled steel frames, a deep V-bottom dump body that could hold material better. Every truck manufacturer in North America had to study that machine and figure out how to copy what they could. Kress moved to Caterpillar, and Caterpillar, being Caterpillar, decided not to copy the Haulpak. They decided to beat it. By January 1963, they were ready. The first Caterpillar 769 rolled off the assembly line at the Decatur, Illinois plant. May 28, 1963, the first unit shipped to a customer. Within months, the machines were running at Kennecott's Bingham Canyon operation. Within a year, they were at mines across Arizona, Nevada, Utah, Montana. Within 2 years, the 769 had become the standard haul truck for open-pit mining in America. The truck that was supposed to come second had arrived and taken the lead. The 769 was 35 tons of payload capacity. That meant when you loaded it with copper ore, waste rock, or mill material, it could carry 35 tons to the processing facility and come back empty. The gross vehicle weight, everything including the truck itself, was about 70,000 pounds. The tires were 18 by 33 inches. These were not casual numbers. Every dimension had been calculated against the ore grades being mined and the haul roads being built. The engine was a Caterpillar D343 diesel, 375 flywheel horsepower in the original 1963 version. This was not a large engine by later standards, but it was matched perfectly to the truck's weight and the loads it would carry. The power went through a transmission, not an electric drive like some competitors were experimenting with, but a mechanical transmission with a fluid torque converter. This was Caterpillar's choice, mechanical reliability over electrical complexity. The torque went to the rear axle, and the rear axle distributed it to the dual wheels. The truck had something that set it apart from everything else on the market at that time: a pneumatic oil suspension system, compressed air, working with hydraulic dampeners. This system did something simple but revolutionary. It distributed the impact of a loaded truck climbing a steep pit road across a longer time. The frame didn't feel the shock all at once. The suspension absorbed and dissipated it. This meant the truck lasted longer. The frame didn't crack. The welds didn't fail. The operator didn't have his spine compressed on every uphill haul. The cab was steel. The steering was manual. No power steering. No air conditioning in most units. The truck ran day and night, and in summer, the interior of the cab reached temperatures that made the metal too hot to touch without leather gloves. But the visibility was exceptional. The driver sat high enough to see the shovel operator's signals. He could see the haul road ahead. He could see where to spot under the bucket. This was a working truck. Not comfortable, not easy, but honest. Every part of it did exactly what it was supposed to do. Nothing more, nothing less. When you started it, you expected it to run. When you put it in gear, you expected it to move. When you loaded it, you expected it to climb the hill. It asked nothing of you except attention and respect, and it delivered. The original 1963 contract specifications promised 95% availability. The truck exceeded that. Operators reported that when they ran these machines 6 days a week, 2 7-hour shifts a day, the 769 was still performing like new after years of continuous operation. The machine arrived at Kennecott's Bingham Canyon mine in 1963 and began operating immediately. Bingham Canyon was, and still is, the largest open-pit mine in the world. The pit cuts down more than half a mile. At the widest point, it's 2.5 miles across. The ore grades in 1963 were low, less than half of 1% copper. This meant that to get enough ore to feed the mill, you had to move massive amounts of material, waste rock, overburden. The economics of the operation depended entirely on moving tonnage efficiently. The 769 was made for this. Every load was money. Every minute the truck spent climbing the haul road instead of returning for another load cost the mine production. The truck's faster cycle time, the engineering advantage that came from its lighter weight, better power distribution, and superior suspension meant more material moved per shift. More material per shift meant lower cost per ton. In an industry where margins were measured in fractions of a penny per pound, this mattered. Caterpillar tested the 769 against competitors in head-to-head performance trials. One documented test in 1963 compared a new 769 against a competitor's 30-ton truck. The test was simple. Run both trucks continuously. Measure how much material each one moved per hour over a full workday. The 769 hauled 54 more tons per hour. 54 tons every hour. This translated to a 29.5% production advantage. A mine operator running these numbers didn't need sales literature. The math was the machine. Within 2 years, the 769 had replaced or supplemented the older haul truck fleets at operations across the American mining belt. At Morenci in Arizona, Phelps Dodge's massive copper mine in the Greenlee County open pit, at Anaconda's mines in Montana, at the copper mines of Nevada and New Mexico, at the coal operations in West Virginia and Kentucky where the machine had been adapted for hard rock mining. The yellow Caterpillar trucks became the standard sight on every major mining operation in North America. By 1964, Caterpillar had increased the 769's power to 400 horsepower. By 1966, the 769B variant appeared with 415 horsepower and a V-bottom dump body to reduce spillage on hauls. These incremental improvements kept the truck ahead of the competition. But the competition was real. Euclid was still building trucks. WABCO was pushing hard. Unit Rig was about to enter the market with diesel-electric technology that some operators preferred. None of them could match the 769's combination of reliability, availability, and cost per ton. The truck that arrived last had become the standard that everyone else had to beat. The men who ran these trucks understood what they had. A truck operator in an open-pit mine was not an unskilled laborer. He was a tradesman. He had to know the pit's topography the way a ship captain knows water. He had to read the haul road's condition, soft spots, washouts, grades that were steeper in certain seasons. He had to know how his shovel operator worked, when he would swing the bucket, where the load would land in the bed. He had to manage brakes on downhill runs where a failure meant the truck wouldn't stop. He had to manage his fuel consumption, his water temperature, his engine oil pressure, all instruments he had to monitor constantly, because there was no computer to do it for him. In the summer of 1963, an operator named Jack Gillen ran a mining and construction company working on a project in Carbondale, Pennsylvania. He had used several different makes of haul trucks. He knew what worked and what didn't. Caterpillar approached him about testing a new 769 against his current fleet. Gillen was skeptical. He had seen new trucks before. He arranged the test anyway, a head-to-head comparison of his existing 30-ton trucks against a brand new 769. What happened next became case study material. The 769 hauled 54 more tons per hour. 54 tons per hour, measured over a full workday. That number compounded across the year, across a decade. Gillen ordered 6 new Caterpillar 769s. 2 years later, after running those machines 2 7-hour shifts a day, 6 days a week, he never looked back. His words, recorded in company files, "On the haul, the 769's superiority really shows up. They're still performing like new. Their reliability has been outstanding. They've racked up over 32,000 hours and given us better than 95% availability. No other truck we've used has come close to that. The 769 spots easier, loads faster, and dumps quicker. 95% availability. In an industry where downtime directly reduced profit, this was the number that mattered. A truck that ran 32,000 hours, 6 years of continuous operation, without major rebuilds, was not just superior, it was legendary. Operators reported that the suspension system made the difference. Climbing a 10% grade haul road with a full 35-ton load meant sustained punishment. The truck's frame, axles, and suspension had to absorb impacts from every uneven spot on the road. Traditional trucks broke things, castings cracked, welds failed. The pneumatic oil suspension in the 769 distributed those impacts across time. The frame didn't have to handle everything at once. This meant the truck survived conditions that destroyed competitors' machines. The mechanical transmission, though it required skill to operate, also proved superior to more complex designs. There were fewer things to break, no electrical components failing in the heat and dust, no hydraulic systems leaking oil onto the pit floor, just gears and bearings that, if maintained properly, lasted. A mine mechanic could keep these trucks running with hand tools and knowledge. He didn't need specialty equipment. He didn't need parts that took months to arrive from distant suppliers. By the late 1960s, the 769 had become so dominant that younger operators knew the truck without knowing the alternatives. It was simply what you drove. The question wasn't whether to buy a 769. It was how many 769s to buy. A mine operator making a purchasing decision looked at the numbers: capital cost, maintenance cost per operating hour, total cost per ton hauled. The 769 won that calculation every time. The Caterpillar 769 ran in American mines for more than 40 years. The original models, shipped in 1963, were still working in the early 2000s. Later variants, the 769B, 769C, 769D, kept the basic design alive as incremental improvements added horsepower and refined the systems. But the fundamental machine that Ralph Kress and his team designed in the late 1950s never changed. It didn't need to. The engineering was right the first time. By the 1970s, larger trucks had arrived. The WABCO 3200 could carry 200 tons. The unit rig Lectra haul offered diesel-electric power that some operators preferred. Caterpillar's own larger models, the 773, the 775, the massive 785, pushed the capacity envelope higher. The 769 wasn't the biggest truck anymore, but it never pretended to be. It was the most reliable truck for mid-range mining operations, for quarries, for construction sites, for any place where a truck needed to work every day without failure. The last 769D rolled off the assembly line in 2007. 44 years of continuous production. Some of those trucks are still in operation today, sitting in museums, or parked at the edge of abandoned pits where they left tire tracks that weather and time have not yet erased. The copper that came out of Bingham Canyon between 1963 and the present day, moved by 769s and the trucks that followed, is still in the country's infrastructure. It's in electrical wiring in homes built in the 1970s and 1980s. It's in industrial equipment still running. It's in the power transmission lines that carry electricity across entire states. The ore was pulled from the ground. It was processed, it was refined, it was manufactured into products that built and sustained American industry. The machines that moved that ore are gone, but the material they handled is permanent. The 769 didn't revolutionize mining. It didn't invent a new category or change how the industry thought about haul trucks. What it did was simpler and more important than that. It proved that a well-engineered truck, built with mechanical reliability as the primary goal, could outperform everything else on the market. Not by being bigger, but by being better. Not by being more complex, but by being more dependable. Not by breaking new ground, but by executing the fundamentals perfectly. That lesson, that reliability and simplicity can compete with innovation and complexity, is the 769's real legacy. For 40 years, it set the standard for what an American haul truck should be, and every truck that followed, whether from Caterpillar or a competitor, had to answer the question the 769 posed: can you do what this machine does but better? Most couldn't. Many tried, but they all had to measure themselves against the truck that arrived second and became first. If this is the kind of mining history you want to keep watching, subscribe to the channel. There are more machines, more mines, and more operations still to document. And if you have a connection to what you just watched, a family member who spent their career in a pit, a grandfather who ran one of these trucks, someone who was there when this era of American mining was still running, tell us in the comments, what did they operate? Which mine? What do you remember them saying about the work? The men who ran these machines didn't write memoirs, but the people who knew them are still here. We want to hear from them.